right, hello everybody. I'm indeed Beth. And today in Programming 2, the cool sequel, we're going to first start talking about literate programming tools and how people use it for data science tasks. So, data science. It's a big term these days. You may have heard it around, and it's a terribly broad term. It's used for almost any situation in which somebody has data and they're trying to yield useful actions or insights from it. So this commonly includes tasks like cleaning data, visualizing it, doing exploratory analyses, and perhaps modeling. So lots and lots of people have use for data these days and want to engage with data. And a very common and powerful way to do this is through programming. And we have a broad range of people who are trying to program with data that we need to consider, including software engineers, scientists, researchers, financial analysts, students, teachers, designers, the list goes on. So, from prior work, we know a bit about how people program for data science. In particular, this kind of programming is very exploratory and experimental. So, if I give you a data set right now and ask you to make something useful out of it, you may not know right away what's going to be the most successful analysis or the best visualization. So you're going to have to start somewhere with an idea, like, okay, what summary statistics should I try? Then you'll make some code to instantiate it, see the results, see what you come up with, and then you're going to iterate. So you're going to keep trying ideas, keep trying avenues until you get to models and analyses that you're satisfied with. And this process is hard. It's hard for a number of reasons. Using statistics as a software development tool is challenging for many people because you need development skills, you need machine learning skills, statistics skills, mathematics skills. So there's a lot of skills to learn. So it's not only challenging to do this exploration, it's also challenging to keep track of it. So we know from prior work that oftentimes exploratory history is lost, and people have insufficient tooling to help them keep track of their exploratory history. So for example, prior work has found that for data scientists working on ordinary text editors, oftentimes software version control like Git isn't sufficient to help them keep track of what they're doing. And why do we care? Well, if somebody comes to you and asks, how did you get this analysis result? Or why did you choose this model instead of 10 other different models? You want to be able to answer that. And oftentimes without history, people just cannot. So we want this transparency that we can actually tell where these important analyses that affect people's lives are coming from. And also for the data scientists, they want to be able to more effectively understand what they've done so far in order to explore. So now we're going to take a look at this very cool and fun new area of tools that have become highly popular for this kind of work, which is literate programming. Now, literate programming is actually a really fun story. It dates way back to 1984, in which Donald Knuth, a researcher, says, documentation for programming is pretty terrible. So I think that we should consider programs to be works of literature. So what he intended was literally, if you have a line of code, underneath you should have formatted English prose that explains your thought process behind that line of code. So that is a whole lot of documentation. And for many reasons we can discuss later, software engineering community did not adopt this idea. But who did, since the 1980s, was computing for mathematics and sciences, because they needed to render equations, symbols, explanations, graphs, and all of these things that literate program really enables. So today we have free and open source tools like Jupyter Notebooks, which is, you see scrolling down on the left. This is the tool that we're going to focus our studies on. This is used by millions of people who are professionals, experts, and user programmers all across the board. And what you see here is you have these chunks of code, which are these rectangular cells, they're called. You can write code, you can run it inline, you can see your output, whether it's textual or visual, inline, and you can also see explanations that you can write about what your process is. So we have these really nice examples that we can grab from online of tutorials and different explanations of fancy analyses, but we really don't know how people use this in their day-to-day work. And interestingly enough, even though this has been around since the 80s, we don't have any behavioral evidence whatsoever on if literate programming actually affects the way people do exploratory work or work of any kind. So we know that literate programming is a philosophy, but do people in real life actually make these nice narratives as they're doing exploratory data science type work? So we wanted to investigate this further. So So here are research questions. We want to find out, do data scientists produce narrative using these literate programming tools? How do they iterate in these literate programming tools? Are there special things that they're doing in this special kind of tool that's unlike other development environments that maybe benefit their process? And finally, do data scientists keep a record of their work through literate programming means? We know from prior work that keeping a record is very hard, but some articles, for example, an article in Nature proposes, these notebooks, you can keep a very nice lab notebook. Like you can say, I tried this, 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 and this. So are people creating actual records of what they tried? And we know that records are not as likely to come from version control tools in terms of fine-grain what all the different things you tried, because currently version control is not particularly usable for this kind of tool. So our methodology. We decided we need to talk to people to get the connection between their ideation and their action in tools during iteration. So we had the opportunity, thanks to the Jupyter project and Bloomberg, to conduct a study during JupyterCon 2017. And this is a professional conference for users of Jupyter Notebook tools. So pretty much we just set up a table and we had anybody walk by. We ended up with 21 participants from a pretty good diverse range of work practices. So we had some university-level teachers and researchers from all around the world, different universities, financial analysts, biologists, software developers, visualization designers, and general-purpose data scientists. And of course, whenever possible, we really wanted to see what people's notebooks look like. Not everybody had their laptop with them or was willing to share, but 4 people did show us their notebooks during the interviews. So all this data we recorded, we transcribed, and we followed a grounded theory methodology to come up with our results. So there are a lot of fine-grained results in the paper, which I invite you to please look into, but I'm just going to share some kind of high-level ones. First off, narrative mattered more to users when they had somebody who needed to read their notebook. And this seems pretty obvious, but people have reported different use cases and different communication goals. So 20 people, everybody but one person, had a use case in which they needed to share the notebook with somebody else. So a classroom full of students, people on their team like collaborators, their clients, or their future self. So 4 people, for example, explicitly said they were trying to make sort of a lab notebook experiment record of all the different stuff they tried. So they wanted their future self to be able to look back at this notebook and say, oh, okay, these are all the things that I've done in my research so far in this past month. 7 people were using the notebooks for a production pipeline, and this meant that they were doing the exploratory phase of their analysis and model building in the notebooks, and they were just going to take out the code and put it in a production system. But even so, oftentimes they cared about the notebook having some narrative because they needed to show it to reviewers or their boss to explain, this is why I chose this model. And if anything happened with the model down the line, like they had problems with it, they wanted to be able to go back to the notebook to understand how the model was produced in the first place with all this explanation that they were able to put in. Where people did not care was this use case called scratch pads. And this was a case where, just like a paper scratch pad, somebody was jotting down something real quick. So they would open the notebook to try out some syntax or to try out an analysis just to, see how it worked. But oftentimes these would be thrown away. So they didn't really care about structure, organization, narrative, unless, of course, sometimes these scratch notebooks would turn into more fruitful analyses, and then they'd be incorporated into a more serious notebook. So participant 13 talks here about they're just using it to figure out syntax. 17 says, they have a whole directory of these scratchy little notebooks, which they don't really need for any particular purpose after they're complete. All right, so explanation. So this literate programming idea, are people using annotations? And the answer is pretty much no. During active exploration, during this data science process, only 6 people talked about using annotations in their notebooks, so like formatted text to explain what they were doing. And only 3 of those people actually used it to explain their thought process. The other 3 were just using like headers to section out their notebook. So this isn't particularly a good sign that literate programming, at least philosophy, is playing out during exploration. Now, more people talked about, at the final stage, once you've got your analysis, once you got your model that you want to share, more people talked about adding annotations at this point to prepare to give it to someone else. So 9 people said this. Participant 10 said, when I'm doing research, it's almost like source code. And then when I really want to clean it up and show it to someone else, then I put in an annotation. All right, so for more discussion on these annotations, stick around for Adam's talk, which is at the end. But pretty much what we got from this is that, per research question 1, do data scientists produce narrative? It's not really looking good for prose explanations of the literate programming style. So for our second research question, how do programmers iterate during their exploration? We want to know, okay, maybe if prose isn't working out, do we see evidence that maybe through the structure of their cells, they're building some kind of narrative? And the answer is yeah. So an important behavior that we documented was what we're calling expand, reduce. So the expand step of this was talked about by 6 people, and this was when you have an idea, such as you're trying to figure out the syntax to something, you're trying to figure out a good plot, you're trying to figure out an analysis. People would add many small cells, try out all these little things in small points. So for example, participant 17 said, at the beginning, it's usually just a lot of little code cells that are one at a time, just making things work, and I end up with this huge mess where there are sort of several threads in a sort of series. All right, so producing all these cells was helpful to test one thing at a time since this is an interactive editor, but it created a bit of a mess. So next was the reduce step, where programmers were motivated to actually clean up their cells. And this was where people would combine cells together and also delete cells that were no longer relevant. And this is really important, actually. So 11 people talked about not only deleting code cells that were I'm trying to figure out syntax and I no longer need this, but they would delete entire analyses, entire alternative routes that didn't work out. And the reason was that these notebooks would get very messy with all these cells. People talked about messiness and cleanliness, that they needed to be able to understand what was going on. So participants expressed that this kind of expand, reduce curation was good to build a story structure out of their notebook. But what it's bad for is that they're throwing out all their stuff. All these record of their experimentation, they're not really keeping through any sort of story here. Now, if you recall, we did have 4 participants whose goal was to keep an experiment record. And how they did it was they largely avoided any curation through expand, reduce kind of practices. They avoided deleting their cells, they avoided combining cells, they sort of left things just as is. But this came at the cost of an excessively messy notebook. So participant 1 said, I can't get an overview of what's going on in my notebook. It's just a lot of stuff and stuff. So our main takeaway from this is that we found evidence that storytelling comes through curation of cells rather than really through prose. And keeping an experiment record through cell structure really does not work too well with building this clear narrative. You can keep an exploratory record structure narrative, or you can create a clear story, but they're not terribly compatible with each other. So we did have another study that we conducted at JupyterCon, knowing that this experiment record is a problem, knowing that version control is a problem. We did a little brainstorming survey with 45 participants, and we wanted to figure out, if we can come up with better designs to keep track of your experiment history, what would you want that to look like? So we had this magical scenario in which we asked participants, pretend you have this magical, perfect record of everything you've done through your analysis. And we wanted to figure out, how would they want to find things, what was important to them about their past, what kind of problems did they run into if they couldn't find things in the past. We wanted more grounded evidence about how people would want to use exploratory history. People generated a number of magical queries, and a lot of these since we used magic to get away from them grounding it in what they thought was possible, so we ended up with a lot of things that are a bit hard to find in search queries, like, how did I get this graph? Or tell me the exact library I used to get this graph, or things like that. And we had things that needed precise history data, such as knowing fine-grained things about runtime, etc., that people just did not have. So there's a lot more discussion of this design area in the paper, which I invite you to look at. But the main takeaway from this is that we'd like to foster curation for cleaner stories so that it's more clear to tell what your analysis is. But we'd also like better ways to automate exploration record so that people have all this history available to them. through improved version control tools. And we also need to work on communicating history, how data scientists remember it, which is through all these different pieces of their analysis, such as graphs, parameters, all kinds of features. So yes, literate programming is a really cool tool that is helping people do more effective data science, but there's still a long way to go to make it actually effective for keeping things like a record of what you're doing. So that is actually the end of my talk. Thank you for your attention.
Thank you very much. So there should be microphones here, down there as well as here. If you have a question, please come to the microphone for Mary Beth. Okay. I want to ask you one. I hope it's not a hard one. Mary Beth, what would you like us to do? What would be the next coolest things that we could do with the results that you just presented? What would you wish the community to do with this? It could be the next thing you do, but what would you wish us to do?
Yeah, so this also comes about in Adam's talk, so stick around for that. There's two kinds of areas. We want to help people communicate their analysis because literate programming tools are really good for this, and this is something that we want to promote. People aren't really using prose for like literate programming tools, but they're still communicating more clearly, and that's a good thing. So we want to enforce that through our designs. But there's still a long way to go in helping people keep an exploratory record. There's more details in the paper on that, but a lot of more tool work needs to be done in that direction.
Yeah. Okay. Thanks.
Hi, Clemens Klockmose, Aarhus University. I might ask this question to Adam again later. How do you see the role of literate programming tools in computing at large? Will it continue to just stick in the data science community, or do you think it will broaden out in other areas of computing?
That's a really good question. So, for software engineering, it didn't really have any uptake, and the reason is that documentation gets out of date, it's very problematic in large systems, and a lot of software engineers think that code should sort of speak for itself, so high quality code should not need documentation. So I don't really see it taking off hugely in large software engineering as we think of it, but where it has come up a lot outside of data science is in education, so in classroom settings, where you have little code exercises and you want everybody to work on it. So I think it's really going to expand more into program education.
Thanks.
Sure.
Hi, Søren Knudsen from University of Calgary. I'm reminded by a paper by Peter Nauer from 1985, where he argues for programming as theory building. And I'm relating this to your work now. It's super great, your work. It seems like you took a kind of a distant approach to thinking about what the process for the people using literate program is. And maybe there would be an interesting perspective in thinking about how they actually use literate programming to also arrive at their solutions, and thinking about the process of how they come up with the solution, basically.
Yeah, I think that's a fascinating topic. So if I'm understanding the question correctly, it's, how do actually people use literate tools, this kind of theory building, to actually ideate and come up with their solutions. So this is a limitation of our current method. We just talk to people. And what we really want to do to study that problem is to actually be able to record people using literate programming tools over, a series of months of their work, and see, how did their ideas evolve actually through the notebook, and talk to them about that. So that's more of a limitation of the data we currently have, but that's a really, really good direction.
Okay. Cool.
Thank you.
Thanks.
Yeah, Henry Lieberman, MIT CSAIL. Great talk. I think what's going on here is that if you're trying to do literate programming like Don Knuth or something, write the world's best programming textbook, it's kind of a top-down process, explain the basic ideas and stuff, and then you kind of get down to the code later on after you're talking about it. But if you're in your Jupyter notebook and you're trying to build up your implementation, it's kind of a bottom-up process. You've got to define all your functions before you call them and stuff. So it seems to me that's where the disconnect is. So maybe we could if we could think about how to get some tools that provide better connections between the top-down process and the bottom-up process, maybe we could drive that golden spike in the middle.
Yeah, that's a good point. So we had a couple people, I'll talk about real briefly, who were instructors. So they're making kind of textbooks or like worksheets for their students. In that case, some of them talked about this top-down process where they would come up with first, what are the main goals of this, and then sort of bottom up, what are my code examples, and there was a connect between that. Where it kind of fell apart was for people who didn't have a clear idea at first of what they were trying to communicate, and then it was completely bottom up. So that might be hard to bridge for these more experimental cases where you don't have a clear message that you're trying to convey.
Thank you.
So when you asked your first research question about whether people write narratives around their data, my reaction was, of course, that's what happens when we publish papers. Mm-hmm. So have you thought about looking at the paper authoring process as another source of insight into what people need in their literate data programming tools?
Yeah, I think that's a really good other area of research. So Adam's paper touches a bit on that because he talked about academics, how they use it for their research process to publish. There's also a lot of interest in literate programming in terms of the publishing community, how to create reproducible and examinable analyses. So that's a really important area. I don't have much insights on it other than I think that's going to be certainly an important area of further research.
Thanks.
Thank you.